Hi, let's begin. In this video, ANOVA test with the help of GPAR. So let me increase this size first. Now it's increased. Now there would be more clarity, more visibility. Now we can see here, this is F test first we will select, and here is ANCOVA. We are not doing analysis on ANCOVA, we are doing ANOVA, fixed effects, omnibus one way. Let me select this part, and a priori, compute required sample size given alpha, power and effect size. Right, so effect size alpha, this one is, you can see here, effect size F is 0.10 is small, effect size 0.25 is medium, and effect size 0.40 is large. And alpha value is 0.05, and power is 1 minus beta. Here is 0.95, and number of groups are 5. So we want to calculate what should be actual power and total sample size. So now what we have to do, we will calculate. And after calculating, you can see here, actual power is 0.95 and total sample size is required 305. And denominator, degree of freedom is 300, numerator degree of freedom is 4. So how we have to, this is our total sample size. Now we want to draw this plot also, and on this plot we can see total sample size, power rather than power 1 minus beta, we have to select effect size. And now graphs interpolate, okay, fine, and 0.95, 0.05, right, draw plot. Now you can see, this is the plot, this is the relationship, effect size when 0.15 and total sample size this, and 0.2 and total sample size this. So we want exact figure, it should be reflected on this curve. So what I have to do, simply I will click here and displaying the values on the plot. And in a step of, rather than 0.05, I want, this is 0.05. A moment I will press and draw plot, right? And now you can see here, this is the exactly on this 0.15 effect size, total number of the sample size is 830. And when 0.2 effect size 469, you can see here effect size is 0.25 and now sample size is 305. That means both are inversely proportional to each other. Effect size, you can see it's increasing, right, and sample size is decreasing. And here is, let's say, digits. You want more than, let's say you want 4 digits, so you can press this, and here is on plot, you can see there are the, and you can increase these digits, number of digits you can reduce also, only 2, right? And in that way also you can see, you can see here is, this is the actual size of the actual sample size on the bar, and it is displaying the values in the plot. Now what I have to do here is, I don't want this. Now I want this ANOVA, right? F test ANOVA, fixed effect one way. Now I want to reduce this effect size 0.10. It should be minimum 0.10. And same alpha and bar is 1 minus beta, and number of groups are 3. So I want to calculate. So you can see total sample size is 1865. That was also on the plot, that was same. It was reflecting when we have drawn this plot. Now I want power is, rather than 0.95, I want standard one 0.80. That is already standard, and number of groups are same. Then I want to calculate. Now you can see total sample size is 1200. But if here is on the effect size, let's say now I want to increase, that should be large. So large means I am changing it 0.40, right? And it is large, and power is 0.80. Now I want to go, so now total sample size is only 80 is required. And as well as what we have to do, ANOVA fixed effect one way. Now I have to click on, here is repeated measures. ANOVA, repeated measures between factors. So here is priori itself, and 0.25 effect size, alpha is 0.05 and par is 0.95. Number of groups are 2 and number of measurements are 4. Number of groups are 2 and number of measurements are 4, and here is the correlation among repeated measures is 0.5. And those are your, we want to calculate this. So total sample size is 132 and actual par is 0.95. So in that way, you can calculate through with the help of G-PAR various ANOVA tests like repeated measures, or if you want to get fixed effects, right, you can do that. But when we talk about ANCOVA, so in ANCOVA, there is the some cofactors also existing, covariance is also existing. Then we have to define these covariance also. Then you could be able to calculate. So I'm sure, and this one is the same way. We have to show this particular, rather than 0.06, we will take it draw plot also, right, in that way. And we want to show these values also, right, but not at the 0.01, we want to show at the 0.05. So now you can see here, these are the actual values are reflecting over there. And simply what you have to do, copy plot to clipboard, and you can paste this chart in your wherever you want to show this chart, this curve on your PPT or your Word document, and you can simply paste this curve over here. So that is the relationship between PAR and total sample size. But I don't want this. I want, rather than, let me increase my size, rather than I want PAR, I want effect size. So moment, then I will press draw plot, and that should be at the 0.05. And now I am going to draw plot, and now you can see this is the total sample size on the y-axis. On x-axis we have taken effect size, and simply what we have to do, copy plot here, and what we have to do, we can paste it on your this PPT or on the Word document. Simply you can paste here. And I'm sure in that way you could be able to calculate what sample size required at this reading. So I'm sure this video will be helpful to you, and I'm sure in the next video we are going to calculate MANOVA and logistic regression also.